Hey guys, welcome to 2.5 Implicit Differentiation. In this lesson, we're going to be talking about a little bit more advanced topics in implicit differentiation. So let's go ahead and get started. It's the same thing like yesterday, except a little more harder. So find the derivative in terms of x and y. Here is my equation. So let's go ahead and do the first part. So it says here, find the derivative in terms of x and y. So I'm going to rewrite this. X times y is equal to 9. If I take the derivative of this, I have a product rule, u times v. In the product rule, we know that it's u times v prime, or you can call it y prime, plus v times u prime. And the derivative of 9 is just 0. Okay? We want to solve for dy dx, so that means I'm going to subtract y to both sides. X times dy dx is equal to negative y. And then divide x to both sides so that I get dy dx is equal to negative y over x. Pretty simple. That's pretty much it. Letter B. Well, there's no letter B, but it says here, then evaluate the derivative at the given point. Here's my given point, x comma y. So dy dx is equal to negative y over x. But when I plug in x is equal to negative 1 and y is equal to negative 9, I really have a negative 9 over a negative 1. These negatives cancel, and it's just negative 9. That is my m, my derivative. So we talked about this before. Previously, you weren't able to plug in both x and y into a derivative because you didn't know implicit differentiation yet. Now that you have a derivative defined as x and y's, now you can plug in a whole point into your function. Second example. Second example, we have find the second derivative notated by d2y dx2 in terms of x and y. So let's talk about this notation. Just to make sure that you guys understand the notation, this also means the second derivative as y double prime. So let's talk about how this notation got derived. So you guys know that the derivative, I don't know, let me write like this. So you guys know that the derivative is d over dx. And if you want to take the derivative of something, it would be d over dx of whatever you want to take the derivative of. But if you want to take the derivative of the derivative, then you'd have two d and dx's next to each other. Well, d and d make a d2. dx and dx combined make a dx squared. And what are you taking the derivative of? Well, I'm taking the derivative of y. So it's this notation here. So let's begin with the first one. So taking the derivative of y squared is 2y. Let me use easier notation. Y prime. What's the derivative of xy? Well, that is a product rule. It's the first times the derivative of the second plus the second times the derivative of the first, which is just 1, equals 0. Okay, so we want to solve for y prime. Okay, if we solve for y prime, we get, let's subtract y to both sides first. So this is 2y prime plus xy prime is equal to negative y. Now I have y prime 2 plus x is equal to negative y. And then divide both sides by 2 plus x. That is my derivative. But notice I want a second derivative. So how do I find the derivative of a derivative? I repeat the same process. So if my first derivative is negative y over 2 plus x, then my second derivative is going to be d2y over dx2. Now I have a quotient rule where the top is my u, the bottom is my v. So it's going to be the bottom times the derivative of the top. What's the derivative of negative y? It's negative y prime minus the top times the derivative of the bottom. Well, the derivative of the bottom is just 1 all over the bottom squared. Cleaning this up a little bit would be negative y prime times 2 plus x. A double negative means it's plus y all over 2 plus x squared. The only problem is that it wants its answer in x and y, and notice here I have a y prime. I know what y prime is. That's y prime. So making a simple substitution, negative y over 2 plus x, 2 plus x plus y all over 2 plus x squared. And I can go even further and cancel out 2x plus 2 plus x, which gives me a, well, look at this. I have a negative and a negative, which makes a positive y plus another y, which makes it 2y on top, all over 2 plus x squared. And this is my second derivative. It says here to check this on your calculator, use implicit differentiation. Well, you guys have the Inspire, and I'll show you how to do that in class. So we don't have TI-89s. Let me go ahead and do this last question in a separate video. So just so that I make sure I don't keep over 10 minutes on my videos, because YouTube will probably cut them off for me, I'll go ahead and finish this off in another video. See you then.